Hi everyone, my name is Kunal and today I'm going to present my project for DA5030 data mining and machine learning. The topic I've chosen for this is time series analysis of S&P 500. I have created a PDF file and I'm going to use that file to show my work. So this is the PDF which I'm going to use. I'm going to follow CRISP-DM method. In this project, there are total six stages. The first one is business understanding, second one is data understanding, third one is data preparation and analysis, the fourth one is modeling, fifth one is evaluation, and the last one is deployment. The first one, business understanding. In this, we are going to define objectives for this project. The first objective is to do time series analysis of S&P 500, and the second one is forecasting the volume of stocks sold in future using three models. Also, as the volume of stock increases, the volatility increases. So to fight this, we are going to take some proper measures. The second one is data understanding. I've taken this data from Kaggle, which is historic data of last 6 years. These are the attributes: date, open price, closing price, then high price, low price, the volume, and name of that particular stock. Here we have imported the data. As you can see, the summary of the data set. Now the third part is data preparation. As there are not many NA values and stock market does not show any drastic fluctuation, so I'm going to replace all the NA values with zeros. Here we are going to perform data cleaning and data imputation. Also, before moving ahead, I would like to tell you that I have taken three companies from various sectors for this project. Apple, which is a consumer product company, JP Morgan, which is financial company, and Gilead is biotech company. Now we are going to plot univariate density distribution and see the graphs for each company. As you can see from the graph, the Apple's graph is not normally distributed. But for this project, we are considering it to be normally distributed. For JP Morgan, the graph is on the left hand side, the distribution, and for the Gilead, it is almost normally distributed. Now we are going to perform correlation analysis. There are two parts in this. First one is intra-company correlation, and second one is intercompany correlation. As you can see from the graph, the this graph is for Apple, the second one is for JP Morgan, and third one is for Gilead. And as you can see, value do not differ that much. And also the Apple and JP Morgan show negative correlation and Gilead shows a positive correlation. Moving forward to intercompany correlation analysis, I have plotted graphs, and as you can see, JP Morgan and Apple are correlated, and if the Apple stocks goes up, it affects the JP Morgan stocks positively. Uh, Now we are going to understand the structure of time series analysis. So this is the high value for last 5 years for Apple, and this is the volume. This is for JP Morgan, and this one is for Gilead. Here I have we are going to detect outliers. So this is the graph. So the first graph shows there are total 30 outliers in this. The first graph shows what would happen if there were no outliers, and this is the effect of the outliers. Now moving forward to feature engineering, I have used ContMod and TTR library, which help us to improve the prediction. Here I have normalized all the features. So moving forward to the fourth stage, modeling. I have chosen three companies: Apple, JP Morgan, and Gilead. Now I'm going to create training and testing dataset. For training, I have taken dataset from 2013 to 2016, and for testing, I have taken dataset of 2017. So moving forward to multiple regression, we are going to perform multiple regression on Apple, and this is the particular graph for this. The red value indicates the true values, and these are the forecasted values. For JP Morgan, the graphs looks something like this, and for Gilead, the graph is now the second modeling is decision tree. Here the red values are true values, and black values are predicted values. Same for JP Morgan and Gilead. Now we are going to perform ARIMA for forecasting. I've performed it on three companies. Now moving forward to model tuning. So we are going to use these parameters: SMA, LMA, ADX, open, close, high and low. And if and we are going to create new model, and if there is not much of a difference between the previous model and new model, we are going to use the model which has less parameters. We are going to less parameters. So the let's go to the first result of Apple, and as you can see, there is not much of a difference between R squared values of old and new model. we are going to use the model which has less parameters. I have done the same thing for JP Morgan and Gilet. Now in ensemble modeling, I have combined all three models in the ratio of zero point 0.4 is to zero point 0.3 is to zero point 0.3, and I've used RMS symmetric here. The fifth stage is evaluation. Here we are going to see which model is better for which company. We are going to use RMS symmetric here. So this is the result, and as you can see from the results, RIMA model is the best model for Apple and Gilet, and for JP Morgan, the best model is multiple regression. So from the result, we could say we studied three models to do time series analysis and predict the volume of S&P 500. In addition, we studied ensemble modeling. Also, from the results, we could say ARIMA model was the successful model for Apple and Gilet. In the deployment, we have created three models successfully, and we have made a report for that. Thank you so much. This was my project for DA 5030 data mining and machine learning. Thank you so much for watching this video.